Today's video will be on surveying and sampling. So we've got quite a few learning goals today. So by the end of the lesson, you'll be able to define a survey, a census, and a sample size. You'll have to identify if a sample is representative or biased. You'll be able to identify outliers and measurement errors in values. You'll be able to classify histograms as symmetrical, skewed, or bimodal. And lucky last, you'll be able to interpret survey results. Okay, so a survey is something that can be conducted to obtain information about a large group by using a smaller sample. And this is often done because in some cases it would be impractical or even impossible to actually survey everyone. So think about it, if you were trying to survey and find out, in Australia, what is everyone's favourite drink? So it would be impractical and it would cost a fortune and take forever to actually go around and ask every single person in Australia, what's your favourite drink? And note that down. So in this case, what we do is we'd actually just do a bit of a survey on a smaller population. So we'd find a population that was representative of the whole. So that means contains a mixed group of individuals, and we'd ask them, and then we just extrapolate that data and apply it as if apply it to like the whole population. So there's also something called a census. So a survey conducted on an entire population is called a census. So I don't know if any of you will remember, but every few years what happens is the government actually sends out a huge survey to every single person in Australia, and every single person in Australia has to answer the survey. And this is called a census. So they conduct a census every few years and they collect all this data from every single person in Australia. So things like their job, their age, whether they're married or not, how many kids they have, all these kinds of things, and they'll actually ask everyone in Australia. But it does take a lot of time and a lot of money, so they don't do the census every year because that isn't practical. So the accuracy of a survey's conclusions can be affected by a number of things. So the first thing is the sample size, so the number of participants or the items considered. So when we're sampling, as I said, we'll use a smaller group and then extrapolate that data to apply it to a larger group, but obviously the sample size could be affected by how small it is. So for instance, if we were trying to find out, for instance, how tall is the average woman in Australia and the only person you surveyed was me, that isn't a very accurate survey. It's too small. Well, you only ask, me and my neighbour Mary, too small of a survey, so you need a larger sample size there. Another thing there is whether the sample is representative of the larger group or biased, which means it can result in the sample mean significantly different from the population mean. Okay, so back to that first example I gave. So if your survey was on what is Australia's favourite drink, and when you were conducting your survey, you decided, I can't actually ask every single person in Australia, so I'm just going to ask a smaller group of people. Let's just say I'm going to ask 400 people, and we'll extrapolate the data. Now, when you were doing that survey, if you stood outside, for instance, an expensive bar in the middle of Melbourne, and you only surveyed the people that came to this bar, your data would be biased because one, it's a bar, so you're only getting people who are drinking, certain types of alcohol. You're only getting adults, and you're only getting a certain clientele who can afford to go to this rich bar. So that wouldn't work. Another example would be, what's your favourite drink and you're standing outside a Boost juice in Caboolture, that's not going to be representative of everyone in Australia. So you need a bit of a mixed sample that could represent the whole group. The last one was whether there are any measurement errors which could lead to outliers, so values that are noticeably different from other values. So is the way that you're measuring going to be incorrect, which could lead to these outliers. And remember, outliers are values that are significantly smaller or significantly larger than the rest of the values. Okay, so just a quick recap on histograms. So histograms, remember, are ways of visually representing frequency tables. So data represented as a histogram can be symmetrical. So we can see here on the left, it's symmetrical, where the left and the right sides are pretty much identical. It could be skewed, so we've got one here that's left skewed, so for instance it kind of goes like this rather than in our normal bell shape curved like our symmetrical data. Or we can have right skewed, which is obviously like the kind of opposite, where it's kind of pushed the other way. We can also have bimodal data, so this is when there is kind of like a double bell curve, so there's kind of two peaks. So if the data is distributed symmetrically, so like our first one here, where it's even on the left and the right side, the mean and the median will be about the same. Okay, so let's do a worked example. So if a survey was conducted asking 100 randomly selected adults, so they've randomly selected people, so this helps making sure that our surveyed population will be representative of a whole population. So they've randomly selected these 100 people and asked them how many children do they have. So the results are shown there on our histogram. We can see there our histogram. So we've got frequency on our y-axis, number of children on our x-axis. So we're going to assume that this sample is representative of the population. Okay, so what proportion of the adult population has 2 or more children? Okay, so 2 or more children. So to calculate that, we have to add up how many people have 2 or more children. So 2, we've got 15 people who had 2 children, 10 people who had 3 children, and 5 people who had 4 children. Out of the total, and the total amount was 100 because they said they had 100 randomly selected adults, so over 100. So that will equal 15 plus 10 plus 5 will give me 30 over 100, and then we can simplify that fraction, so that's 3 out of 10. So what proportion of the adult population has 2 or more children? About 3 out of 10. So 30%, 3 in every 10 adults we would assume would have 2 or more children. It's a lot of children. Okay, so B, in a group of 900 adults, how many would you expect to have 4 children? Okay, so the first thing you're going to do is find out how many in the 100 would have 4 children. So that was 5. So 5 out of 100 would have 4 children, but we want to find out how many out of 900. So we're just going to multiply that by 9. So that will give me 45 out of 900 would have 4 children. So if we had 900 adults, we'd expect 45 to have 4 children. Therefore, 45 of 900 adults would be expected to have 4 children. There we go. Okay, so move on. C. Is this distribution symmetrical, skewed, or bimodal? Well, if we have a go like this, that's how our distribution is, and the center is here, so it's definitely not symmetrical. It's not bimodal, so we would say that it is skewed. So you can see it's all been pushed there towards the left. It's heavy down the smaller end. So more people having 0 or 1 children than they are having, 3 or 4 children. Okay, D, which of the following methods of conducting the survey could lead to bias? So method 1, asking people waiting outside a child care centre how many children they have. Okay, would this lead to bias? I'm going to say yes, because if you're outside a childcare centre, there's probably a reason, and that reason is you are picking up or dropping off your child. So that would be biased, because you're only really going to get people who have children answering that survey. That or people who are, creepy kidnappers or something. But no, that would lead to bias because the people at the childcare centre probably have children. That's why they're at the childcare centre. Method 2, randomly selecting people. So randomly selecting is good. People at a nightclub and asking them how many children they have. Not so good. Okay, so if you're at a nightclub, a bit of a stereotype here, but I'm going to generalize. In my experience, people who go to nightclubs are usually young, so they're usually, under 25, and they usually don't have children because, they can go out and drink and dance, and be at clubs. So I'm going to say that would also be biased. Even though you're randomly selecting, your location is going to be biased towards people who don't have children. The last one, randomly choosing adults from the national census and noting how many children they have. So this would be the way to do it, because this will be unbiased. So remember, a census surveys an entire population, so you would have every single person in Australia, all their data. You'd randomly choose people from that data, so just picking numbers, looking at that, and then noting down how many children they have. So using our tally method maybe. And you would note down how many children they have, and that wouldn't have any bias, because if you're randomly picking them from the entire population, there shouldn't be any bias at all. That's the end of our video on surveying and sampling. Hopefully that was nice and clear for you, but as usual, any questions, come and see me.